Hi everyone, my name is S. Venkatesh. Today we're gonna discuss data integration in data mining and data integration in data mining. Data integration is the process of merging the data from several disparate sources. While performing data integration, you must work on data redundancy, inconsistency, duplicity, etc. In data mining, data integration is a record pre-processing method that includes merging data from a couple of heterogeneous data sources into coherent data to retain and provide a unified perspective of the data. These assets could also include several record cubes, databases, or flat documents. The statistical integration strategy is formally stated as a triple GS M approach. Represents global schema, and S represents the heterogeneous source of schema, and M represents the mapping between source and schema queries. And mainly, data integration indicates that the uh, uh, integration of the data from multiple sources, either it is a um, data warehouse, uh, databases, multiple source of databases, collecting the information from multiple sources and merging the data into uh, one place. What is data integration? It has been an integral part of data operations because data can be obtained from several sources. It is a strategy that integrates data from several sources to make it available to users in a single inform view that shows their status. There are communication sources between systems that can include multiple databases. Data cubes or data flat files. Data fusion merges data from various diverse sources to produce meaningful results. That consolidated findings must exclude inconsistencies, contradictions, and redundancies and inequities. Inequities. Data integration is important because it gives a uniform view of scattered data while also maintaining data accuracy. It assists the data mining program in meaningful mining information, which is done assists the executive and managers make strategic decisions for the enterprise's benefit. And the data integration methods are formally characterized as a triple G comma S comma M, where G represents the global schema and S represents the heterogeneous source of schema and M represents the mapping between the global schema and heterogeneous source and global schema queries. Why is data integration important? Companies that want to stay competitive and relevant welcome big data and all of its benefits and drawbacks. One of the most common applications for data integration services and technologies is market and customer data collection. Data integration supports queries in these vast data sets, benefiting from corporate intelligence and consumer data analytics to stimulate real-time information delivery. Data integration is particularly important in the healthcare industry. Integrated data from various patient records and clinics assist clinicians in identifying medical disorders and diseases by integrating data from many systems into a single perspective of beneficial information, from which useful insights can be derived. Effective data collection and integration are also improve medical insurance claims processing accuracy and ensure that patient names and contact information are recorded consistently and accurately. Interoperability refers to the sharing of information across different systems and data integration approaches. There are mainly two types of approaches for data integrations. These are as follows: tight coupling and loose coupling. Tight coupling refers it is the process of using ETL extraction, transformation, and loading to combine data from various sources into a single physical location. And loose coupling refers to the packs the with Loose coupling are most effectively kept in the actual source databases. This approach provides an interface that gets a query from the user, changes it into a format that the supply database may understand, and then sends the query to the source database without delay to obtain the result. Issues in data integration. When you integrate the data in data mining, you may face many issues. There are some of the issues. Entity identification problem. As you understand, the records are often from heterogeneous sources. And how can you match the real world entities from the data? For example, you were given client data from specialized statistics size. Customer identity is assigned to an entity from one statistics supply, while a customer range is assigned to an entity from another statistics supply. Analyzing such metadata statistics will prevent you from making errors during schema integration. Next one, redundancy and correlation analysis. One of the major issues in the course of data integration is redundancy. Unimportant data that are no longer requires are referred to as redundant data. It may also appear due to attributes created from the use of another property inside the information set. For example, if one truth set contains the patronage and distinct data set as the purchaser's data, the beginning. The age may be a redundant attribute because it can be reduced from the use of the beginning date. And double duplication. Information integration has also handled duplicate tuples in addition to redundancy. Duplicate tuples may also appear in the generated information if the denominated table was utilized as a deliverable for data integration and data warfare detection and backup. The data warfare technique of combining records from several sources is unhealthy. In the same way that characteristic values can vary, so can statistic units. The disparity may be related to the fact that they are represented differently within the special data units. For example, in one of your kind towns, the price of an interim might be expressed in a particular currency. This type of issue is recognized and fixed during the data integration process. And data integration techniques. There are various data integration techniques in data mining. Some of them are as follows: manual integration. This method avoids using automation during data integration. The data analyst collects, cleans, and integrates the data to produce meaningful information. This strategy is suitable for a mini organization with a limited data set, although it will be time consuming for the use sophisticated and recurring integration because the entire process must be done manually. It is a time consuming operation. And next, middleware integration. The middleware software is easy to take data from many sources, normalize it, and store it in the resulting data set. When an enterprise needs to integrate data from legacy systems to modern systems, this technique is used. Middleware software acts as a translator between legacy and advanced systems. We may take an adapter that allows two systems with two different interfaces to be connected. It is only applicable to certain systems. And the next one is application-based integration. It is using software applications to extract, transform, and load data from disparate sources. And the strategy saves time and effort, but it is a little more complicated because building such an application necessitates technical understanding. The strategy saves time and effort, but it is a little more complicated because building such an application necessitates technical understanding and uniform access integration. This method combines data from a more disparate source. However, the data's position is not altered in this scenario. The data stays in its original location. This technique merely generates a unified view of the integrated data. The integrated data does not need to be stored separately because the end user only sees the integrated view, data warehousing. This technique is related to the uniform access integration technique in a roundabout way. The unified view. On the other hand, is stored in a different location. It enables the data analyst to deal with more sophisticated inquiries. Although it is a promising solution and increased storage costs, the unified data sleeve or copy requires separate storage and maintenance costs. And next one, integration tools. There are various integration tools in data mining. Some of them are as follows: on-premise data integration tool, open source data integration tool, and cloud-based data integration tool. On-premise integration tool and on-premise data integration tool integrates data from local sources and connects legacy databases using middleware software. And next one is open source data integration tool. If you want to avoid per se interface solutions and an open source data integration tool is the ideal alternative, although you will be responsible for the security and privacy of the data if you are using the tool. And cloud-based data integration tool. A cloud-based data integration tool may provide an integration platform as a service. So, friends, this is all about data integration. So, thank you.